Sex linkage is a genetic phenomenon that happens when inheriting a certain condition is more common in one sex than the other, or having that condition is more common in one sex than the other. And that happens when the genes for those traits are located in the sex chromosomes. For many species, sex determination, which gender the individual is going to be, depends on what combination of chromosomes that individual has. In humans and fruit flies, females have two X chromosomes while males have one X and one Y. Birds are actually the opposite. In birds, females have a different set of chromosomes while males have two Z chromosomes. And in insects, in some insects is usually the females have two X chromosomes and the males have missing one, or like in bees and some other insects, the diploid organisms are the females, and then being haploid is the male. So we're gonna look more specifically at a human example in which females have two X chromosomes and males have one X and one Y. Here, for example, we're seeing this sex-linked condition that is having white eyes, and the gene for eye color is located on the X chromosome. Fruit flies, like humans, females have two X chromosomes, so this is the female and her two X chromosomes, and males have one X chromosome and one Y chromosome. In this case, the female is normal. She has red eyes, and both of her X chromosomes have the allele for normal red eyes. And the male has white eyes, since the gene for white eyes is located on the Y chromosome, on the X chromosome, sorry. His only X chromosome has that condition, but there is no equivalent for eye color in the Y chromosome. So this results because the Y chromosome has fewer genes than the X chromosome. So the alleles in the X chromosome for the male will be the only ones that will be expressed. While on a female, since she has two X chromosomes, a recessive condition must be present in both X chromosomes in order to be expressed. If it's only present in one, then the other copy that has the dominant allele will be the one that is expressed. So let's look at the result of crossing this normal female with this male. And since the female has normal X chromosomes, she will give a normal X chromosome to each one of her offspring. And since the male has the X chromosome with the white eye gene, and his other chromosome is the Y chromosome that has no genes for eye color, the females of this cross will have the normal X from the mother and the mutated X from the dad. The males only inherit the Y chromosome from the dad and inherit the X chromosome from the mother. Since the mother has both normal X chromosomes, then the males will all have normal eye color. So again, note that since females have two X chromosomes, even though this female has the mutated X chromosome, the normal chromosome is the one that is expressed. So she still has normal eyes even though she carries the condition in one of her X chromosomes. So now let's look at the scenario in which the female is heterozygous. She has a normal X chromosome and a X chromosome with red eyes, and she mates with a male that has normal red eyes and his X chromosome that doesn't carry any genes for eye color. So what is the offspring going to look like? So again, remember that the X chromosome in the male will be the one that goes to each female, while the male offspring will receive only the Y chromosome from the dad, and their X chromosome will come from the mother. And here, this female, she received a normal copy from the mother and a normal copy from the dad. Here she received a defective copy from the mother, but she still has the normal copy from the dad, so she has normal eye color. And the males, they received the Y chromosome from the male, from the dad, and the X chromosome, half of them received the normal X chromosome that the mother has, and the other half received the white eye chromosome, or the chromosome with the white eye allele from the mother. So half of the males would have white eyes. So notice since half of the offspring receive the Y chromosome, half of the offspring will be males, so this is this half here, And the female will give half of the male offspring will have the normal copy, and the other half will have the mutated white eye copy. Now, what would happen if the female is heterozygous and the male has only white eyes? So here again, the female will give half of her offspring the normal X chromosome, and the other half will receive the abnormal one. For the male, he will give his daughters the white eye chromosome that is the X, and to the males, he will give the Y chromosome that has no genes for eye color. As a result, half of the females will have all the females will have this mutated white eye from the male they got from the father. Half of them will get the normal copy from the mother, so they will have normal eyes, and the other half will receive the abnormal copy from the mother, so they will have white eyes. From the males, their X chromosome comes from the mother, so if they get the normal X chromosome from the mom, they will have normal eyes. If they receive the chromosome with a white eye mutation, then they will have white eyes, and half the males will receive the normal version and half the males will receive the white eye version. There are several conditions in humans that are sex-linked. One example is color blindness. The most colorblind people are men, and color blindness is more common in men because it is sex-linked. It's located on their X chromosome. And hemophilia is also a sex-linked condition that is also located in the X chromosome, so it's more common in males. And this is a very common example because this is a pedigree of the European royal families, and they're all connected to each other because they married, intermarried, and there was a common case of hemophilia in the Russian Tsars, and it's now known that all those hemophilia cases can be traced back to Queen Victoria being a carrier of hemophilia, so she was not a hemophilic herself because she had one X with the hemophilia allele and another one with the normal allele. But she passed that trait to her offspring, and some of her sons had the trait, and some of her daughters were carriers who would then give that trait to their sons. So the way to spot a sex-linked trait is to see if the trait is present more likely in males than in females. So here we see that the affected are all squares, which are the males. The females that are carriers are shown as a half circle, and this is because they don't have the condition, but they had to be the ones that carry the alleles. So they're not affected, but they are carriers. So when you see that one gender is more likely to be affected by a condition than the other, you can say that this is a sex-linked condition.